Light gives us safety and security. Thus, the lighting system plays an important role in the modern vehicle. Hi, I'm Palmer. In this module, we'll explore how lighting is used in automotive applications. The lighting system's primary function is to illuminate the exterior and interior environment, as well as increase the visibility of the vehicle. Certain parts, such as indicators and brake lights, allow others to gauge what the vehicle is intending to do. It also provides a means of style and design, adding character and enhancing aesthetic. There are a number of different bulb types that are used in vehicles to provide courtesy lighting in the form of brake lights, interior lighting, and indicators, to name a few. Bayonet-style bulbs have been around for a long time. They get their name from the two retaining pins on the side of the base. The pins follow slots in the side socket and at the bottom, and the slots turn sideways into a small pocket. The pin position and offset can be different to ensure the correct bulb is installed. At the bottom of the base is either a single or dual electrical contact, depending on the type of bulb. A modern update of the bayonet bulb is the wedge-style bulb. The base is formed into a wedge typically made from the glass bulb itself. The bulbs are pushed straight into the socket, and tension from the socket retains the bulb. The electrical contact on the glass-based bulbs is made by wires extending from the base of the bulb and bent over opposite sides of the wedge. Another commonly used bulb style is the festoon bulb. It consists of a small glass cylinder with a filament attached to a metal cap at each end. They are available in different lengths and diameters depending on the application. These are only available as a single filament bulb. They are generally used in lower wattage situations such as number plate bulbs and interior bulbs. Up to now, lights with amber coloured glass bulbs have been used as direction indicators. Some indicator bulbs have a silver appearance yet light up amber. When switched off, they are barely visible in the silver reflector. The amber light is only radiated at the usual brightness once they are switched on. The application of several interference layers on the glass bulb of the light quenches certain shares of the light spectrum radiated by the filament. Only the amber share penetrates the layers and then becomes visible. Now, let's move on to headlights. The task of the vehicle headlights is to focus the light beam generated by the light source onto the road ahead under all environmental conditions. In headlights, most vehicles require two beams to provide for a high beam and a low beam operation. The beams are created by separate filaments included either in one light bulb or in separate bulbs. These filaments must be positioned correctly in relation to the highly polished reflector. This is called focusing and is carried out when designing the light assembly and lens for the vehicle. The low beam is an important component of vehicle lighting and is a statutory requirement for every vehicle. The essential purpose of the low beam is to provide safe lighting of the road at close range without dazzling other road users. Special requirements therefore exist in relation to the luminous intensity and light distribution, which is generally asymmetrical. The low beam also ensures that the vehicle is easily visible to the other road users in the dark. In contrast to the low beam, the high beam illuminates the road to the maximum possible extent. The high beam is therefore predominantly used on very dark sections of road without oncoming traffic, where it is difficult to see what lies ahead, thus significantly increasing visibility and therefore safety. The sealed beam headlight is a self-contained glass unit made up of a filament, an inner reflector, and an outer glass lens. The standard sealed beam headlight does not surround the filament with its own glass envelope. The glass lens is fused to the parabolic reflector, which is sprayed with vaporized aluminium that gives a reflecting surface that is comparable to silver. The inside of the bulb is filled with argon gas. The reflector intensifies the light that the filament produces, and the lens directs the light to form the required light beam pattern. The lens is designed to produce a broad, flat beam. The light from the reflector is passed through concave prisms in the glass lens. Lens prisms redirect the light beam and create a broad, flat beam. This is to control the horizontal spreading and vertical focusing of the light beam, preventing upward glaring. In a semi-sealed beam headlight, typically a replaceable halogen type bulb with a pre-focused collar is used. The collar locates the bulb in the headlight assembly and also controls the correct positioning of the filaments to the reflector and lens. Some halogen bulbs have a partial shield below the low beam filament. This shield prevents light from the filament from striking the lower part of the reflector, which would be reflected higher than the midpoint of the bulb. The shield provides the primary shape of the low beam. The final shaping of the beam is carried out by small cylindrical prisms in the headlight lens. This provides a low beam that is asymmetrical. The asymmetrical lens pattern causes light to be thrown upward at a 15-degree angle on the curved side to better illuminate objects, persons, or animals close to the road. The high beam element is positioned to create a focused, narrow beam which maximizes the light's range and intensity. Headlight systems have traditionally used reflector-type lighting. In a reflector headlight, the light from the bulb is reflected forward by a specially shaped reflector. By placing the filament in different locations on the reflector, the direction of the light beam is controlled. The high beam filament is positioned at the focal point of the reflector to project the maximum amount of light forward and parallel to the reflector axis. This light is then shaped by the lens, which is made up of many small glass or plastic prisms fused together. These prisms bend the light horizontally and vertically to achieve the desired light pattern for road illumination. The low beam filament is often placed above and slightly offset to the focal point of the high beam filament. Mounting the low beam filament in this position produces a beam of light that is projected slightly downward and towards the offside. With this arrangement, the high beam filament produces the most concentrated light output, whereas the low beam filament gives a downward and dispersed beam that is less likely to dazzle oncoming drivers. In these type of headlight assemblies, the reflector has a paraboloid surface. This is the oldest technology used in headlight light distribution. Parabolic reflectors aren't really used today, though they appear occasionally in high beam headlights and large H4 headlights. Freeform headlights have reflective surfaces which are freely formed within the space. The reflector is divided into different segments which illuminate different areas of the road and surroundings as required by the manufacturer. Almost all modern reflection headlight systems for low beams are fitted with freeform reflective surfaces. Projector headlights are high-performance headlights which were originally only available in luxury vehicles. Now this technology is commonplace on all makes and models of vehicles. This type of headlight uses a lens system rather than the traditional reflector system to project light forward. They are capable of illuminating more road surface at greater distances by projecting a more highly focused beam of light than traditional reflector headlights. This means more light is emitted in front of the vehicle where it's needed and less light is lost out to the sides. Most projector headlights use the following four main components for operation: bulb, reflector, shutter, and lens. The projector headlight works similarly to the reflector style, with the bulb casting light onto a reflector. However, that is where the similarities end. The design of projector headlights is based around the idea of focusing light with a specially shaped reflector. The light is then cast towards a focusing lens via a shutter. If required for low beam operation, it blocks the lower portion of the reflected light before passing through the specially shaped focusing lens. This provides a highly focused beam of light that typically results in more luminosity when compared to the same wattage globe in a reflector type headlight. For high beam operation, the shutter is retracted or pivoted away, removing all restrictions from the light beam. A projector style light predominantly uses HID or LED bulbs. However, some earlier applications used halogens. Lighting is, and always has been, a critical part of every vehicle. The modern vehicle still pays homage to its predecessors from the early 1900s, with some of the lighting principles utilised today. Therefore, understanding the principles of vehicle lighting is a key part of your skill set as a technician. I'm Palmer, keep training, and thanks for watching.